Hi guys. Today we're continuing with adding and subtracting rational expressions. Yesterday we focused on fractions who had monomial denominators, so we didn't have to do any factoring. Today our main focus will be on polynomial denominators, so there's going to be a lot more factoring today. Let's jump in. Here is our first example. Now there's a very specific set of steps that you should take, and I'll have a slide later in the video that you can write down those steps, but I'm going to walk you through right now. To start these problems, we're going to focus on just the denominator. So we're going to kind of ignore the numerators for the moment. When we're focusing on the denominators, we're going to start by factoring because that's what we do in algebra class, right? So much factoring. So I'm going to go ahead and factor both my denominators. They're both x box. And so for my first fraction, I'm going to get x plus 3 and x minus 2. And then for my second fraction, I get x minus 2 and x minus 1. So I want to point out something else that I did on this problem, and that is I changed this from a subtraction problem to an adding problem. So the reason is that we are subtracting this entire second fraction, and at some point in time, that second fraction is going to get a little bit more complicated, and we're going to need to remember to take this subtraction sign and distribute it to the entire second fraction. Now, if it's just a subtraction sign in the middle, we might forget to do that. We might just say, oh, yeah, okay, I'm subtracting. And we might forget to distribute it to everything that's happening in the fraction. So what I like to do straight off the bat is I like to distribute it immediately so that I don't forget to do it later. And I'm not distributing at this point in time, right? I changed it to a plus sign and I made this a -2. And that -2 is going to become important in our next step. All right, so now I've created factored denominators, and now I'm ready to find my LCD. And we practiced this during our live session. Just like yesterday, when you're trying to find your LCD, you're basically making both the fractions have the same denominator. And so on the factored problems, I like to kind of look at them both and ask myself, like, okay, what does the other fraction have that this one is missing? Okay. So right now, both of the fractions already have in common, right? We're getting a common denominator in x minus 2. That's what they have in common. But my second fraction has an x minus 1, and my first fraction is missing that. But if I want them to be exactly the same, then I need my first fraction to have an x minus 1. So I'm going to multiply my first fraction by x minus 1. Top and bottom, you will need to distribute this 3. And my first fraction has an x plus 3 that my second fraction is missing. It doesn't have one. And so, if I want them to be exactly the same, I need to give my second fraction an x plus 3. Top and bottom, this is where it's going to be important that we made that to a -2 so that the negative sign gets distributed. All right, so now I've created my common denominator. I wrote it up here as well. My common denominator contains those 3 parentheses. Once you've created a common denominator, you're going to start ignoring the denominator because it's not going to change. The denominator is going to stay the same for the rest of the entire problem, and it's going to stay those 3 parentheses. So we don't need to put any thought into the denominator. We can kind of just like leave it be. Now we're going to start focusing on the numerator. We need the numerators to be adding and subtracting problems. We need there to be no multiplication. So I am going to distribute my 3 and I'm going to distribute my -2. Just like yesterday, once you have a common denominator, you can take your fractions and smush them into a single fraction. When you smush them into a single fraction, your denominator does not change. Whatever your common denominator was, that will stay the same for the rest of the problem. And then with your numerators, you're just going to create a really long adding and subtracting problem. So again, no multiplication at this point in time, adding and subtracting. Okay, so here, right, it was 2 separate fractions. I did 3x minus 3 plus -2x minus 6, right? 3x minus 3 plus -2x minus 6. So I just made the top a really long adding and subtracting problem, and then I kept my 3 parentheses in my denominator. Since the numerator is adding and subtracting, next I will be combining like terms, right? That's the concept of adding and subtracting. So I will combine together my 3x and my negative 2x, and then my negative 3 and my negative 6. At this point in time, you should try to factor your numerator. Okay, so x minus 9, that doesn't factor, but sometimes you are going to get a numerator that does factor. Also, you should check for canceling. Now, I have an x minus 9 on top, but I don't have any x minus 9s on the bottom, so nothing will cancel. That means that my fraction is as simplified as it can get. And then you can see I already wrote my restrictions on the screen. The restrictions come from the common denominator. You actually could have written those down as soon as you found your common denominator. Since my common denominator had 3 parentheses, I get 3 restrictions. Let's go over those steps one more time. So we start the problem by focusing on the denominator. And if you can factor your denominators, you have to factor them. That's mandatory. You want your denominators as factored as possible. Once you're done factoring your denominators, you're going to create your LCD. You're going to compare the two fractions and ask yourself, what does this one have that this one's missing? Okay, we'll give it that missing thing. Or sometimes it's multiple things, right? Now, what is this one missing? So that they're both identical. After you've created your LCD, you're going to not do any more math with the denominators. They're going to stay the same for the rest of the problem. Now we're going to shift our focus to the numerators. So I'm even going to write in a different color. So then we're going to multiply out the numerators. So in the process of creating your LCD, you multiply the top and bottom. So you do need to actually multiply out whatever was on top. In the example we just did, we distributed. Sometimes you might have to do the box method. You might have 2 binomials and you might have to do the box method. But you want to multiply out your numerators until it's adding and subtracting only, no multiplication. Then we're smushing the fractions together and we're combining like terms in the numerators. So we're condensing, right? Making it smaller. The next steps don't always happen, especially on adding and subtracting problems, but you still have to try and see if they do happen because sometimes they do. And you don't want to miss it when they do happen, and you don't want to just assume it's not going to happen. So next, try to factor your numerator if you can. And then, if your numerator can factor, maybe you can cancel. Even if it can't factor, maybe it's already going to cancel with something on the bottom. So then cancel if possible. And these last two don't happen very often. So they do happen sometimes. But it's okay if you never get anything to actually cancel on an adding and subtracting problem. That's actually the most common thing that will happen. All right, now I'm gonna have a second video because I think these problems are difficult. I wanna run through a couple more examples, but if you wanna get a head start on the second video, these are the 2 examples I'm gonna go over. So if you wanna try these on your own first, go ahead and write them down on a piece of paper, try them on your own, and then when you're done, you can start the second video, and I'm gonna talk about these 2 problems in the second video.